Wheellock pistol that dates from 1560, which is a very, very early pistol. We're going to get into a lot of detail on it because we're going to restore it. I'm taking this picture with the pistol on the floor because it's 30 inches long overall. The barrel's about 21 inches long. And this would be about the only way I can show the whole pistol. Hereafter we'll be showing portions of it up close. The lock is missing, which is the main problem, and it has some condition problems as well. We're going to talk about some of the more specific things we have to deal with in a few minutes. Here we're looking at the lock inlet with the lock missing, of course. And the back side here is sort of an open tubular affair. This is seen on a lot of very, very early guns, that type of sight. French wheel locks are different from the usual, the Germanic type, I'll call it. The spring is enclosed in the wood. Get a little more light on it. And it has a floor plate that reaches from where you see the opening here, there, all the way back to here, which is where the end of the mainspring is. The mainspring wraps around a pin that goes through where that hole is. Piece of ivory or bone, if that's what it is missing there. And there's a strip of ivory, bone, if that's, it looks like ivory, or some bone that is more dense than bone I have, anyway. On the butt cap, there's a piece that's missing there, as you can see. And there's a lot of these little tiny pieces missing in the, there's one right in the center, missing there. And in the center of that, a lot of that, and there's the one circling that piece of decoration that's missing. A lot of that. This is the other side of the lock area, as you can see from the front sight, the breech and so forth. This area here is the main bearing for the crankshaft, the outer main bearing in the wood. The Germanic ones have it all the lock complete, but the French one depends on the stock to do part of the lock mechanism. So far, the only work I've done is lower this barrel. It was being hung up by about 1/8 of an inch of seating where it needs to be. It's now down where it needs to be, and I put a pin, actually it's a piece of bamboo from a chopstick from a Chinese restaurant that I pushed through there to retain it, because the barrel, the bit that sticks out of the breech plug has a hole in it, and a screw goes through there in the complete gun that retains the barrel. It does not have the usual hole in the top of the barrel tang. The front, the muzzle is retained by, as you can see, rubber band. And I glued this piece back on. It kept falling off, and but I just glued it enough to hold it. It's not a final repair. It's just, there's so much of this that's loose that when I have to go around and do something to tighten up these little things that are sticking out or about to fall out, we're going to be snagged, because in the process of restoring this gun is going to be an awful lot of handling, and we don't want it to get worse because of the handling. Typically, I shouldn't say typically, I'd say fortunately, this ramrod seems to be the original ramrod. It has a long metal end on it. That crud that you see on there is part of rust where it had rusted into the, stuck into the wood there. Barrel is in pretty sad shape in some respects. Part of this rear sight has gone wherever rusty sights go because it's missing it and just rusted away. I can probably repair that to where it looks better. Anyway, the next step is to stabilize some of these little parts. Now we're going to get into making the lock. First thing I did was make a template out of sheet brass, fairly thin, to fit down into the wood inlet. Now we'll make it into 3mm, 1/8 inch thick steel. It's shaped and fitted down into the wood, down to sitting down in it as it originally should have been. That drill centers where the crankshaft will come through. This is the bearing outside. This is the lock we see again. The hole in the center there. That is where the crankshaft comes through once it's installed. There's the outer bearing that we've made for it. Typical of French wheel locks, the outer bearing is in the wood rather than metal supported. Here we're making some inlet on the inside of the lock plate for the mechanism. Here is a piece of rough material that we used to build the crankshaft. There's going to be a lot of show and tell here on the crankshaft for a while. There is a German Wheellock pistol of about 1640. We're going to use the design of the crankshaft as a model. We're not going to duplicate it, we're just going to look at it for what we can learn as we build our own. And here's some of the first work on building our own crankshaft. Here it is down in the wood. You can see it's aligned. Here's the German crankshaft with the chain on it. We're having to build the chain. There's the first link of our chain. We build the chain link by link. There's what the chain looks like up close. Now here we're going to see it in motion. We turn the crankshaft. Notice it pulls the pliers up into the, which is the same as compressing the spring. Here's our chain and the crankshaft. The bottom of this gets cut off to a T-link that fits in a fork in the end of the mainspring. That was our little chain. Here's the square filed on the crankshaft for winding the wheel, turning the wheel and winding it. Now we're going to make the wheel itself. This is made out of an old piece of trailer hitch. It's 1/4 inch thick. I laid it out, made the hole, and I've got the crankshaft sticking into the hole there. There it is. It's a pretty good fit. There we are, come out the other side. Now we're making the wheel itself. I sawed it out roughly. Now I'm turning it on the lathe to the diameter determined by the distance between the center of the axle to the bottom of the vent hole in the barrel. There we are, vent hole in the barrel in the top there. Now that's the rough material for the pan. It's a piece of bar about 1 inch wide and 1/2 inch thick. There's a roughed out pan. A little more work on the pan sitting in place. Here we've laid out the indentation or the pan cavity itself. There's a fitting there, the forward end of the pan to the lock plate to center it, and there we are, bolted up to fit against the barrel. Screw there that holds it. There it is. The pan is about 5 millimeters deep, 16 millimeters in diameter, lined up with the vent into the barrel. This is a small template made of sheet brass that we're using to locate the cut in the bottom of the pan, because it has to have the notches there, and you have 2 diameters, one which is the depth of the notches in the wheel and the other is the full diameter. Here we are, having fitted and filed it, the notches there, which are there for making better spark, is the purpose of the notches, of course, but they have to fit through the bottom of the pan and fit well enough that the powder doesn't escape through the openings. Here's some of my doodling and diagramming that I often do in these jobs. Here we're getting ready to make the pan cover. There's a slot there for the little arm that operates the pan cover. This work gets very intricate at this point. There's our roughed out pan. It's sticky and rough, but it's going to work. That arm is attached on the inside of that screw there, and that screw is used on the outside to support the wheel bridle, or the retainer for the wheel. The other end is on that, the wheel is fitted to that screw we just saw. Here's the inside of the pan cover. The turning of the crankshaft when you fire the gun pushes the pan over, pushes the pan cover open. Here's the roughed out wheel cover, wheel bridle. It gets some tabs welded on it to receive screws. One there where the finger's pointing, one up on the other side there. There we go. This gets, now that we get a lot of material off of it, it looks a little better. There it is. Pretty well done, pretty well completed there. So we have a working wheel, chain, wheel cover, there is the mainspring in its rough form. Clock spring steel, SAE 1095 steel. I bend it and shape it, work it around to get it where it wants to be the right shape. I make a rough test of it even before it's tempered, just to make sure it'll work. Here's how it sticks out underneath the bottom through that little opening in that lower plate. There's the trigger we showed coming out the side of that bottom floor plate. Here's the end where the chain hooks. I had drawn the shape that I wanted that spring to be on the piece of paper, which we check it against after we've got it tempered. And we'll do a little test here. Just to make sure we're not bound up with the wood or something. It passes the test. Just about the right length. There we go. Turning it way around there. I let the camera wander while I was trying to turn the thing. You let it go, and it is a spring. And there's the shape of it, as it should be, as it wants to be. I tempered that spring in my kitchen oven. It was too big to do as I normally do. That was some more sketching. That was a temporary cam that I was working with to decide the shape for that can that operates that pan cover. There we go. I had to play around with that quite a bit to get the right shape to make it do what it's supposed to do. And not everything that I did worked out the first time, or even the first 2 or 3 times. Eventually it all came together and worked properly. Here we have it in a vise. And there's the actual pan cover lever, we'll call it, with the crankshaft in place. My opaque fingers don't help the photography here. I had to doctor up this camming area of that crankshaft. You can see. We'll demonstrate that in just a moment. We wanted to have a lifting effect rather than just a pushing effect on that pan cover lever. And we've taken off some material for clearances here and there. Here we go. That little arrow that I scratched on there, you can see, that was just to show that's the contact point where the turning of the crankshaft lifts the pan lever and opens the pan. Like that. There we go. So much for that. Now for another little test here. Gonna let that go like firing it. Watch the pan open. There we go. The pan opens in about the first 45 degrees of rotation or less. Now we're getting into the trigger mechanism, sear mechanism. That's a sear rocker, we call it. It goes through the lock plate and engages with the depression in the wheel. There's where the actual sear effect occurs, back there, as you'll see when we develop this a little further. There we are, we've got a notch there. When that pushes back, there's a mechanical lock there. We push the sear back, it allows the rocker to move, releasing the wheel. Like that, it moves down. Here it is. A little further along, we've made the spring there. It's a V-spring, one end pushes this sear into position, the other pushes the sear rocker up, which engages the wheel when the depression's in the right place. You can see the latching section. Now we build a safety. This safety, there's very little in this that's a copy of old stuff, because this gun was done at a time when there wasn't anything to copy. There were so few of them. 1560. This is my own contrivance. It does have a feel. It has a snap to it, and it has a stop that keeps it from going too far in either direction. It latches there down at the where the end, there we go, the lifting that and turning that there. We've turned the safety lever, which keeps that sear from moving. Effective, simple but effective. Probably the only one in the world made like that. Another little demonstration of how it moves in only one direction. Here we're looking at a spring that gives some feel and snap to the pan cover mounted inside the lock. When the pan covers move in one direction, it drops into a depression on the lever. The other direction, it kind of hooks over the edge of the lever. It gives tension and keeps it from flopping around and gives it feel. Here's another sketch of what we're doing here. This is what is more commonly called the dog's head. It holds the pyrite. That is a series of weldments and filings and tappings and turnings. Here's a spring, a very strong spring, also made out of the same material that we made the mainspring. I built up the inside of that, where the screw goes through, to give it the effect of a nut there. It's just some welded on material that thickens the lock plate at that point for the thread of that screw. There's a lot of force on that screw and it needs a good thread. Here it is all together. There's a little demonstration of this way the safety works. Now we're looking at the floor plate being made. It has to have a hole cut in it for the end of the spring and the chain to come out. That was typical on all of those early French Wheellock pistols. There's the screws that hold it into the wood. I made them in the 16th century style. There it is in place. There's the hole with the chain and spring peeping out through it. Here's our trigger guard, which I attached with a kind of a sheep foot hook